Hey, what's up, guys? Today we're going to be looking at a lab from Jeremy's IT Labs about standard access control lists. And so let's just dive right in. The first instruction is to configure OSPF on R1 and R2 to allow full connectivity between the PCs and the servers. Okay, so we got a serial connection here. We're going to open the CLI on R1, enable. T. We're going to check to see if there's any protocols running currently. So we do that with, well, we're already in configuration mode, so we're going to go do show IP protocol. And so there's nothing currently running on the router. And so we're going to enable OSPF. We're going to do that with router OSPF. I'm going to say the instance is 1. And from OSPF configuration mode, we're going to have to figure out which interfaces we want to participate in OSPF. And so we are going to initialize OSPF on this segment here, so this subnet, but on these serial links. And so to do that, we're going to say network. Then the network address 203.0.113.0, and we're going to put in the wildcard mask 0.0.0.3, I think, and also area, and it's going to be OSPF area 1. It's not specified on the topology diagram, so we're just going to use 1 and enter. Okay. And so now we can say do show IP protocol, and we can see that OSPF 1 is running on router 1. So let's go do the same thing for router 2. Enable, configure terminal, and we're going to do, again, we're going to check to make sure there's no protocols already in place on router 2. So show IP protocol, do show IP protocol. I'm already in config mode. Do show up. Okay, so there's no dynamic routing protocols on R2 currently, so we're going to do, we're going to enable OSPF, so router OSPF, also going to just call it 1. And so from here, network 203.0.113.0, 0.0.0.3 wildcard mask. Also, it has to be in the same area as the other segment, or as the other interface on R1, in order to become OSPF neighbors. And so, see here, we should have some OSPF neighbors. And so do show IP protocol. Okay. And so, yep, OSPF is running on router 2 now. Okay. So do show IP IP OSPF interface is brief. And so we got one interface running OSPF in this segment here between these two routers. Okay. All right, our next instruction is configure standard numbered access control lists on R1 and standard named access control lists on R2 to fulfill the following network policies. And so the network policies we're going to want to fulfill it. Only PC1 and PC3 can access 192.168.1.0. Okay, that's this segment, this subnet here. And so we also have hosts in 172.16.2.0 can't access 192.168.2.0, and let's see, 172.16.2.0. Okay, that's this subnet here cannot access 192.168.2.0, and that's the subnet here. And so let's just do it step by step. And so let's just handle the first requirements first. And so only PC1 and PC3 can access 192.168.1.0. So we are controlling access to 192.168.1.0. And so whenever you're dealing with standard access control list, the rule of thumb is to put the access control list as close to the destination network as possible, or the destination subnet as possible. And so we're going to configure these restrictions, or this filter or ACL on G00 interface of R2. And so we're already on R2 exit. And so on R2, I think it said to configure standard numbered access control list on R1 and standard named access control list on R2. So two different ways to do it. And so on R2, we're going to be doing standard named access control list. And so what that means is, instead of just being identified by a number, it's going to actually be identified by a name, and you have to configure those two separate ways. So for this network on this interface, we're going to go ahead and create this access control list. And so to configure a standard named access control list, we have to say IP access list standard. And the course I was taught, a lot of my CCNA studies is going through Jeremy's IT labs, as well as the official cert guides. And so whenever Jeremy does these labs, and whenever he configures these named access control lists, he uses the IP address to identify the access control list. And so I'm gonna do the same thing, because it just makes it easier whenever you're going back to view and verify which access control list is configured on which interface. And so we're going to say standard, and then we're going to name it to 192.168.1.0. And so that's going to be the name of our control list. Enter. Okay, now we are in standard standard named access control list configuration mode. So here we can put in our ACEs, so our entries, access control entries, so that we can let's see what it asked us to do. Only PC1 and PC3 can access 192.168.1.0. So we're going to be enabling just two nodes here, just these two specific hosts. And so let's do PC1 first. And so we're going to do here it's optional. You can put an entry number first, but we're not going to put an entry number. We're just going to say permit. It's going to be PC1's IP address 172.168.1.1. And a couple ways you can do specific hosts. You can do it with the host keyword before the IP address. You can specify a 32-bit subnet mask, or a O.O.O.O wildcard mask. And we're just going to do it like that for right now. And so we're also going to permit 172.16.2.1, and you can just leave it blank, and it will and iOS will understand that you only want to enable or permit this one host. And so we're just going to hit enter here, and we're going to verify it. Do show access list. Okay, and so we have access list to 192.168.1.0. We're going to permit host 172.16.1.1, that's PC1, and we're going to permit host 172.16.2.1, and that's going to be PC3. Okay, so that should be that for that host list. Now, just because we've defined the host list doesn't mean that it's taken effect. We have to actually assign it to an interface. And so we're going to do that now. X, and we're going to assign it on the G00 interface. So interface G00, and so we're going to it's a little different. You don't configure, it's not, the command is not access list, it's actually access group. So in order to assign access lists to 192.168.1.0, you would say IP access group, and then you would name the access group. So to 192.168.1.0. Okay, now you want to specify whether you want it inbound or outbound on this G00 interface, and we're going to want to have it outbound. So any traffic coming from anywhere on this network, on this topology, is going to, if it's coming from this direction, it's going to flow from R1 over to R2, and then once it gets to R2 and R2 realizes it's for the 192.168.1.0 subnet, before it goes out, is going to check the access control list. And so we got that configured. Now let's verify it. And so a way to verify, there's not really a specific way to verify which interface and access control list is, which interface and access control list is assigned to. But I did look up earlier how to do that whenever I was learning this. And so do show include include line protocol and access list. Okay. And so now here we can see each interface on this router, and this is the output here. Okay, and so we're going to be looking for G00 to verify that our access list, outgoing access list, is applied to the G00 interface. And so there it is. All right. And so next, well, first let's okay, let's try pinging server 1 from PC 1. Yeah. Ping 168. Okay, we're going to reply from 172.16.1. 172.16.1.254. Okay, we I forgot to enable OSPF on the other subnets. Let's see. Show IP route. Yeah, so we have no dynamically learned OSPF routes currently, and so to show IP OSPF neighbor. Oh, not the do command. We're not in config mode. There we go. So yeah, we only got, which we're only going to have one neighbor because there's only 2 routers on this topology, but we need to enable OSPF on as passive interfaces on these other subnets so that our entire network knows about each other. And so let's do conct router OSPF 1, and let's do 172.16.1.0. We forgot the network command. network. And then we're going to do area. We've got the area 1. Okay. And let's also do 2. Now you show OSPF interface to show IP OSPF interfaces. Okay. Yeah, let's do show OSPF. Okay, OSPF is active on all the interfaces, but these 2 interfaces we need to make passive. And so we do that by, let's look at our options. Interface G and passive G01. Oops. Int G01. Okay. All right, now running for networks, we have 2 passive interfaces, G00 and G01. And same thing over here. Okay, so yeah, now we have 172.16.1.0 learn dynamically and 172.2.0 learn dynamically. And let's enable OSPF on these 2 interfaces so that our 1 can learn routes to 192.168.1.0 and 192.168.2.0. So network OSPF 1. I'm in a router OSPF 1 network 192.168.1.0 .255 area. I forgot the area command again. Area 1. And same thing with 192.168.2.0 area 1. Alright, now let's go back to, let's move ahead just a minute and let's see if router 1 has learned some new routes. Do show IP route. And okay, now we have routes to 192.168.1.0 and 192.168.2.0, and let's make these 2 passive like we did on the other one. And so we're going to do passive interface G00 and passive interface G01. Alright, let's do protocol. Alright, we got our 2 passive interfaces and all our networks there. And now, since we got that access list configured on G00, now let's try to ping server 1. Okay, looks like we are getting replies from server 1. Now let's try to ping server 1 from PC2. Ping 192. 192.168.1.100. Okay, now from PC2 we're getting destination host not reachable. So that's what we want. And let's try one more time from PC3. Desktop, command prompt, ping 192.168.1.100. And we're getting a reply. Okay. Alright, we got the first reply there because a lot of the ARP had already been done after PC1 tried to ping server 1. So we got a pretty immediate reply from server 1 to PC3. Alright, now moving on. Let's do hosts in 172.16.2.0 can't access 192.168.2.0. And so we don't want these hosts to be able to access this subnet. Okay. And it doesn't say anything about anything else. And so let's go back to router 2. Let's exit here, and we're going to create another access list. So another standard named access list. So we're going to do IP access list. We're going to name it same naming convention as earlier to 192.168.2.0. Oh, forgot standard. You got to have that standard keyword here. Standard. Okay, so now we're in standard named ACL configuration mode. Now we can list our access control entries. And so first, there's going to be two, but the first one is going to eliminate the entire subnet of 172.16.2.0. I want to say deny 172.168.2.0 0.0.0.255 because it's a /24. Yep. And we are going to, it doesn't say to deny any other traffic, and so because of the standard access list controls tendency to implicitly deny anything that's not listed, we're going to have to list everything else. So permit any, and so that's going to catch everything else. So the only thing that's blocked is any traffic coming from the 172.16.2.0 subnet. Okay. Alright, now let's do show access list. Alright, we got our two access lists here, and should be good to go. So now we just need to apply it to the G01 interface. And so let's go to G01, and we're going to do IP access group to 192.168.2.0, and we're going to specify it as out. Now I'm going to say do show, let's run the command we ran earlier, do show IP interface include line protocol access list. Alright, so now on gigabit 00 we have the two 192.168.1.0 access list, and on gigabit 01 we have the two 192.168.2.0 access list. And so we got the two access lists configured on R2 to handle these first two requirements. Now the third requirement is that 172.16.1.0 cannot access 172.16.2.0, and 172.16.2.0 cannot access 172.16.1.0. And so we do not want these two networks, these two subnets, interacting with each other. And so these, we're also going to have two access lists configured on R1, but these access lists are going to be standard numbered access lists. And so let's exit OSPF config. All right, we're back in global configuration. And so here we're going to configure access list 1, which is going to keep any traffic from the 172.16.1.0 subnet accessing 172.16.2.0 subnet. And so in order to do standard numbered access lists, it's a little different. All you have to do is do access list, we're just going to call it 1, and we're going to say permit, or deny anything coming from the 172.16.1.0/24 network, but it doesn't say to deny any other traffic. And so we're going to access list 1 permit any. And so that's going to give us our first access list on R1. And let's check, do show access list. And so here we got access list 1, and we're denying all traffic from 172.16.1.0/24 and permitting everything else. And so we're going to go to here. Let's go ahead and create our other access list. So we're going to do access list 2, and on access list 2 we're going to deny all traffic coming from 172.16.2.0/24 and approve and permit all other traffic. And we're going to go to interface configuration mode, G01, and we're going to apply access list 1 on G01 and access list 2 on G00, or access list 2 on G00. Let's see, IP access list 1 out on G01. Oh, access group, I'm sorry. See, you got two different keywords for that, access list and access group, if I can type. And we're going to go to interface G00, IP access group 2 out. And so now we can do show access lists. So we got our two access lists. Access list 1 denies all traffic from this subnet going to this subnet, and access list 2 denies all traffic coming from this subnet going to this subnet. Alright, and so with that, I think we are done with the lab. Let's just try to we're going to try to do one ping to see if we can let's exit, or let's just end to go back to enable mode, and let's try to ping 172.16.2. Let's try to ping PC3 from here. Okay, we got PC3 from here. Now let's try to ping PC3 from PC1. So ping 172.16.2.1. Is that right? 172.16.2.1. Yep. All right. Destination host unreachable. Okay, so we can reach PC2 from here. I mean, PC3 from R2, but cannot reach PC3 from PC1. So it looks like everything's working as it should. Let's try one more ping. Let's make sure we can reach PC1 from router 2. Ping 172.16.1.1. Okay, yeah, we can reach PC1 from router 2, but I'm betting we cannot reach PC1 from PC3. Destination host unreachable. Alright guys, that's going to be all for this lab. I hope you learned something. I hope you enjoyed it. Until next time.